I've always enjoyed chatting with Chris informally around many, many ideas we're both interested in, so this should be just as enjoyable. I'm not quite sure where to start. I mean, I love the way you're doing this.
Oh, thank you.
Yeah, and it's always fascinating when you take things from a completely different perspective and arrive at those same conclusions. So, as you say, what's it all mean? None of us know what any of it means, really. I mean, what I'd really love to do is to sit down and go through your whole presentation in slow motion for about 6 hours and like step by step by step, because there's many points where I say, well, hang on, or what's it? But maybe to start off, a couple of things. And this is, this question is about consciousness and observation. Mm-hmm. And as you said, the classical view is that we are entangled systems and observation is part of the interaction within an entangled system. You were saying that was the classical view, more or less.
Well, the classical physics doesn't have the notion of entanglement per se, so that's really a quantum view.
I mean standard quantum physics.
So that is a standard quantum view.
Yeah. So,
and I completely agree with that.
Yeah. The question is, why do we need to assume consciousness in that as observation? Cannot an observation be a purely physical thing? Does it have to have a subjective thing? And maybe we mean different things by consciousness, but when I'm talking about consciousness, I mean that thing of actually having a subjective inner experience of the world out there. Is that how you're using consciousness when you say all observers have to be conscious?
Yes. And the departure I would say that a large departure that I would say that I make from most people who work on quantum theory is there's an assumption in, I would say, standard interpretations of quantum theory, in the Copenhagen interpretation, the many worlds interpretation, quantum Bayesianism. Bohm is slightly different. Any theory with a physical collapse is slightly different. But standard interpretations where there isn't a physical collapse, there's still a very strong assumption that classical information is objective. So what do I mean by classical information? Our experience of the world is entirely classical. That means that when I look at that projector, I see a particular thing with well-defined characteristics that I can describe. It's this big, it's white with a black front, it's got a lens in it, it's got wires coming out of it. It's located right there, and it's been there for the last hour. Those are all descriptions in language. And I could write all of those descriptions down as a string of bits. So if I were to write those sentences down in my computer, then somewhere on the inside they'd be represented just as strings of bits. And those strings of bits would be finite. I've made a finite number of observations. I've given you a finite number of descriptive terms, and I've given them to you in a finite amount of time. Okay? So the assumption in most interpretations of quantum theory is that that classical information, that finitely statable information, is objective. And that's often stated by saying classical information is fungible. You can write it down on a piece of paper. I can give it to Peter. Peter can look at it, and what Peter sees is independent of anything other than Peter looking at it, right? Once I wrote it down, it was done. It's fungible information. And that's distinct from what's called non-fungible or unspeakable quantum information, in which if I give Peter an electron with some spin, then what he observes may depend on what I'm doing over here with its entangled partner. So that kind of information is not objective. But there's a belief that classical information is objective. Mm-hmm. And I reject that altogether. I say classical information is experienced, and that's all. Classical information is purely subjective. And in this, in a sense, I'm following a good tradition. There's a long tradition in physics that says that there's no such thing as objective chance. Probabilities are all purely subjective. And the Bayesian view of probability, which you may have heard of, is a purely subjective view of probability. Probability is all about knowledge. It's not about objective chance out there in the world. So, for example, quantum Bayesianism is an approach to quantum theory that's based on the idea that all probabilities are subjective, but quantum Bayesians still assume that classical information itself is objective. And I just say, no, classical information is experience. All of our experience is classical. Let's just say all of classical information is experience. So that's why I require that observers be conscious. Because if an observer is acquiring classical information, and classical information is just experience, then they have to be experiencing it.
Okay, but as I was watching your presentation, I was thinking, but maybe I'm wrong here, that it would all hold up without the observers being conscious. The whole universe is observers, and I was feeling everything you were saying would still make sense, even if the observers were not conscious observers, even if they were classical observers. I mean, quantum classical observers.
Yeah, okay. That's certainly true if you believe that classical information is objective. Yeah.
Okay.
I mean, for my view to make sense, you really have to reject this idea that classical information is objective. Mm-hmm. But it's an idea, I think, that has absolutely no empirical support whatsoever. It's a straight philosophical assumption.
Yeah.
And it's, in a sense, exactly the same as the assumption that the observer-world distinction is an objective distinction. Mm-hmm. So, in a sense, rejecting the objectivity of classical information is a way of rejecting observer-observed duality. It's a way of saying that boundary between the observer and the world is not an objective boundary. It's just a boundary that may be apparent to some third parties who are observers. And I actually take that back to developmental biology. If you think about how a human infant, or probably infants of any other species, come to realize that their body is theirs. You know, they're doing motor babbling. They say, oh, I feel this move, I feel something moving, and I see something moving, maybe it's the same thing. And this sense that you are a distinct thing has to be built up over time through experience. So from a developmental biology perspective, it's very much a cognitive construct. And, you know, I mean, looking at what's going on, they're now doing fMRI with infants that are 3 months old. And you can actually see these representations wiring themselves up in the brain. You can see, you know, kids learning that the world consists of things. It's interesting. I mean, this is a process that happens after birth.
There's another thing I want to pick up. You mentioned the measurement problem, mm-hmm. but all you did was mention it.
Right.
Could you elaborate on that? I think it's really important. You were saying there is no measurement problem. But could first of all say, what is the measurement problem as it's usually understood?
Okay, well, the measurement problem as it's usually understood is motivated by a simple question, right? Which you can phrase in terms of Schrodinger's cat or anything else. It's the question, why don't we see superpositions? Right? If quantum theory says the whole world is in a superposition of all possible states, and we look around at the world and we don't see that, right? Mm-hmm. Your shirt looks green-ish. It's not yellow, it's not red, and it's not somewhere else. Mm-hmm. So I don't see your shirt as in a superposition of all possible states of your shirt. And the assumption in the early 20th century as quantum theory was being put together was that what the theory describes should be directly reflected in what we observe. And superpositions were not directly reflected in what we observe, but they were there in the formalism and there was no way to get rid of them, and that's what makes quantum theory different from classical theory. So out of this distinction between the representation that the theory gives to reality and what we observe, this gap from quantum to classical was invented. And crossing that gap, how to cross that gap, is the measurement problem. And all interpretations of quantum theory are there to try to solve the measurement problem, to try to say why classicality emerges from this underlying quantum reality, where the underlying assumption is that quantum reality is small, right? Quantum theory was invented to explain experiments on atoms. Atoms are little bitty things. So throughout the Copenhagen interpretation, the idea is that quantum theory is about these really little things. And for great big things like us, we don't have to worry about it. So the quantum world, if there is any such thing, is a world of little tiny things that we can't see. And the classical world is just classical. But note this is assuming that classicality is objective, that classical information is objective, and that classical objects are objective. And if we reject that assumption, if we say classical information is all in the head, or all in consciousness, more accurately, that problem goes away. And we can say, yes, we're seeing superpositions all the time. That's what's out there. We don't see them as superpositions because our experience is classical. Our experience couldn't be anything but classical.
Isn't there an option, though, or a possibility that, this is how I've understood it sometimes, that as we go up from the quantum level and start getting larger and larger accumulation of systems, that gradually the quantum effects get smoothed out, so to say, and once you get like 10,000 or so atoms together, you're moving into a classical system just because the quantum effects are just being cancelled out, putting it very loosely.
Yeah, that's basically what decoherence theory says.
Yeah.
That the environment is large and classically random. And so its classical randomness cancels out any quantum effects. Well, notice here that we've assumed that the environment is classically random. So we're actually, in decoherence, assuming classicality in order to demonstrate classicality, which is circular. Mm-hmm. So my first comment is that this is circular. But my second comment is that it's actually wrong. And it's wrong because it involves an assumption that's also ubiquitous in science, that we know what the causes of our experience are. So we assume in science that my experience of that projector is actually caused by a physical object that's that projector. We make that assumption all the time. That, my experience of this is caused by this and not by something else. But there's no evidence for that. And if you think about it, it's probably wrong. And here's one way to think about it. Again, think about how much information I actually have about what's in my hand. Right? And that amount of information has to be finite. Well, why? Well, here's one reason why. I can look at it and I can start to say things about it, and the total number of things I can say is finite. I could write them all down as a finite bit string. But the other way to think about it is, if acquiring information requires energy, I can only use a finite amount of energy to acquire information about this glass. Right? If I was using an infinite amount of energy up here, none of you would exist. Right? Because I'd be much bigger than a hydrogen bomb. Okay? So I'm not using an infinite amount of energy. I'm using a very tiny amount of energy to learn about this glass. But without using an infinite amount of energy, I'm only getting a finite amount of information. So I have a finite amount of information about this thing, but it's information about a part of a world that, as far as I know, is infinitely large and infinitely complicated. So my information about this glass is actually massively ambiguous. And in the limit of an infinite universe, it's infinitely ambiguous. So this glass could be any of an incredibly large number, probably an infinite number, of different physical systems. But I think of it as just a glass because all of those different physical systems that I could be getting information from are giving me the same information. And as long as I'm getting the same information, I can't tell what I'm dealing with. All I know is the descriptions that I have of it. And now there's some neat mathematics. If you write down a mathematical theory of what it means to have only a finite amount of information that's in the limit infinitely ambiguous as to source, the math you get is quantum theory. And what the math does is represents this as a superposition of an infinite number of different systems that give me exactly the same outcomes to within my measurement resolution when I act on them with the measuring processes that I'm actually able to execute. So when I act on them with my ability to measure distance, mass, color, anything else that I can measure, an arbitrarily large number of distinct physical systems could give me the same answer. So this is just a superposition of that arbitrarily large number of systems.
Which comes back to one of the early interpretations of the collapse of the wave function, that it's a collapse in our knowledge. Mm-hmm. Yeah, so our knowledge then becomes knowledge of a particular system in that sense.
Right.
Yeah.
Yeah, our descriptions collapse onto what they were to begin with, which were finite sets of bits that we've somehow associated as names with something or other in the world.
Let's turn it over and see what other questions there are. There's a few.
When I hear you talking, sounds like you're talking as if there is a system and we're getting knowledge about it, presupposing the existence of something that we're getting knowledge about, therefore we can acquire information about it. But it seems to me it's more that the only reality that some object has that you're talking about is in its consequences for the one who is supposedly observing it. So more it seems to me that information is generated by the process of observation, and the object, is, in as much as it exists, is generated by the process of observation. And so that the energy that you take, that you need, that you talked about, is energy that you use to generate the object in as much as it exists, because it doesn't physically exist. There's no physical existence. The only existence it has is its consequences for all of the observers that interact with it. And the observers aren't the same. Like a rock's universe is completely different from our universe. And a cat even is different. So their experience of the system is completely different. Does that make sense, what I said?
Yes, it certainly makes sense to me. I think it's sensible to think about each observer interacting with exactly one thing, which is that observer's entire world, all the rest of the universe except that observer. And all of the objects in that world are are constructs of the observer, and the world of an observer only has the objects in it that that observer can detect by making measurements. But I think behind your question is a question about realism versus idealism, in a sense. You know, is there a physical world out there? And I tend to be a philosophical realist, but by, in a sense, pushing realism to the limit where it's almost indistinguishable from idealism. You know, if you take quantum theory completely seriously and you deny even the objectivity of classical information, then if there's a world out there, including me, then that world consists of quantum information and nothing else. And what does it mean to say that quantum information is real? Who knows? Maybe it means exactly the same thing as saying consciousness is real. I think we can just use these terms interchangeably and be perfectly happy about it.
Okay, did you want to...
Well, first of all, thanks for a wonderful talk and very stimulating. All those coincidences you explored are new to me and very interesting. I'd like to comment on one of the basic assumptions you made and kind of suggest a modulation of it. You said all interaction is observation. I would add to that all interaction which conserves information about something. First of all, when we talk about observation, we talk about observation of.
Right.
So all interaction in which some information is conserved about that of is observation proper. What I mean is like, let's say we measure the position of a particle and then we measure the momentum of the particle before the position has interacted with any other system. You wouldn't call that a measurement of position,
Right.
because that information got lost. It's like in the quantum eraser situation.
Right.
So that's crucial because the so-called measurement problem disappears when you look at it in that perspective.
Yes, I think that's exactly right. I mean, if there is an interaction which does not involve sufficient action to transfer a bit, then there's no bit transferred. And so in a very weak measurement, for example, you're trying to create an interaction that's weak enough that there's not an irreversible consequence on either side. And so I think I agree.
That's what I mean, yeah.
Very good point.
Just something else on that, which I've pondered a lot with the uncertainty principle, that the uncertainty is Planck's constant. Mm-hmm. This is, I mean, just what you were talking about, when you measure like this, the position or the speed of a particle, the uncertainty is the uncertainty that comes out, the lack of accuracy between the two is actually Planck's constant, which is, what you're saying is one bit of information, which makes sense because it means, well, of course we couldn't measure something more accurately than one bit of information. And of course we couldn't measure something more accurately than one quantum of action, because that is the indivisible unit, which almost says that Heisenberg's uncertainty principle is a logical conclusion of the fundamental action being Planck's constant, or one bit of information in your terms.
Yes, I think that's exactly right.
You'd expect Heisenberg's uncertainty principle to come out of that.
Right. See, I think if Shannon had invented information theory in 1920 or 1900, and quantum theory had been invented 20 years later, instead of the reverse, which is what actually happened, then we would all see quantum theory as just a consequence of classical thermodynamics.
Great. Yes.
There's some synergy there. I'm actually sending you a paper on local observations and how to combine general relativity with quantum theory, which is just accepted for publication. I wanted to ask a bit of a theoretical question because, of course, he's gone. But in reading von Neumann's, particularly the last chapter of his book, the quantum, I don't know the German name, but anyway, I got the sense that he was already going in the direction that you and I have gone, namely that, in fact, there's no cut and there is just the whole thing is conscious or the whole thing is mind-like. And it's actually interesting if you do take that point of view, because some of the interpretations, including Henry Stapp's present interpretation, are still dualistic, whereas I think von Neumann was already moving in the direction of one unity of consciousness. Do you care to make a comment on that?
Well, von Neumann was a really bright guy, so.
Right.
And I think, as Peter was just saying, this is, in a sense, a logical conclusion just of classical physics.
Right.
I mean, I think we could say, or I would say at least, that quantum theory is just classical physics done right, without making assumptions that things are insignificant that might, in fact, be significant.
But just to close that thought, his comments that the cut, the Heisenberg cut between classical and quantum world is arbitrary. If you take that to its logical conclusion, arbitrary means actually it's nowhere.
Yes.
Yeah, thank you.
I agree.
Yeah.
John?
Yeah, thanks. You make so much come to sense, which is so complicated usually. I thank you for that. I'm very interested, you mentioned in passing, a little bit in passing, that you can observe the construction of concept within the child's mind if you put them in an fMRI. And I think those, and really I'm coming at this from the point of view of conscious awareness and how we form the dualistic perspective. How do we fall out of the one into the many? Could you comment to the role that memory actually plays in this? In that if there's this construction, which I wholeheartedly agree with from the day of birth, of that reality supposedly out there, there is almost an agreement that has to be made at some level, whether it be within a species, whether it be within a population group of any kind, that suggests that actually the memory that we hold of the agreement is actually the thing that creates that dualistic experience, that outside there, which, if one has the fortune of stepping outside of that dualistic experience and actually having the non-dualistic experience, you do realize actually is just an agreement. It's not actually real. Could you comment to the role of memory? Because I think it's something that brings it down for me, certainly to the experienced, and gives it a lot of accessibility, because I don't think it's that far away from everything that you're suggesting about the bit of information and the transfer of that, and how that works. I'll leave it at that.
That's a fascinating question, and you bring up 3 different topics that I would say no one understands the connection between, and this is a wonderful area of research. So here's some things that we know, right? We know that the part of the brain called Brodmann's area 10, which is right here, right? Sort of where the third eye ought to be. If this is damaged by trauma or stroke or something like that, then people tend to lose a very interesting collection of capabilities. And one of the capabilities that they lose is being able to distinguish memories from other experiences. And they lose the capability of distinguishing their memories from the memories of someone else. So they start to lose the ability to say, oh, this is a memory and this is my memory. So think about it. I mean, you have a memory, it's just an experience. How do you know that that's a memory experience as opposed to a visual experience, for example? I mean, it's lighting up your visual system. And if it's an episodic memory of action, it's lighting up your motor system. And all that's very well documented experimentally. So how do we make that distinction? I would say no one knows. And it seems to have something to do with what's going on in BA10, but who knows what. So there's one idea that you brought up, which is a vast unknown in neuroscience. So here's a vast unknown in developmental biology, right? We all learn from other people. Human learning is intrinsically social. And infants learn from the other people around them to regard things as objects and as separate. And once you start giving them names, once language comes on, then this really goes up. But if you look at the experimental literature, then experiments have been done, for example, showing infant scenes where the experimenter does the analog of picking up this glass and the table comes with it. And infants typically in the beginning aren't surprised at all. They see no reason why this shouldn't be just one thing. But after a certain moment, they start to be surprised if you pick up the glass and the table comes with it. And that's intimately coupled with what they have been able to observe, what you have shown them, and what they're able to do themselves. But no one really knows how that works, how that social learning works. We just know that it is social. And we know a little bit about what the sequence of things that are typically learned is, at least among children in Western cultures, who are the only experimental subjects here. And then you bring up a third topic, which relates to the extended mind hypothesis that Andy Clark introduced some years ago, but lots of people now work on, which is to what extent are objects in the world actually encodings for us of our own memories? So, we all know that the first thing you learned as an undergraduate was you don't need to learn everything, you just need to learn how the library is organized, right? So you can take your memory and stick it in a building, or you can regard the stuff in the building as your memory. But that's probably true from day one, right? The items in our house, by assuming that they're the same thing over time, by assuming this thing called time, we can store a lot of our memories in our environment. And if we didn't assume this thing called time, then we couldn't. So time is incredibly useful. But again, how that works, we don't know. We don't know how people use objects in the environment as part of their memories. So I'd say great question, great project for the next 50 years.
One little thing on memory and time, and this is just purely a subjective observation, there does seem to me to be some sort of time code on a memory, by which I mean I have an approximate sense of how long ago that memory was. And it's not just because I'm remembering my childhood, so it must be 50 years ago. It's not that sort of thing. I notice it more interestingly with dreams. I'll suddenly remember, a dream's broken. Oh, that's a dream I had last night. Or, oh no, that's a dream I had several days ago. Or, oh no, I had that dream a month ago. And it's some sense of time. It isn't that memories they just appear as an experience. They do have some sense of time in them. It's very vague, but there's something there that I can know how long ago that memory is coming from, very approximately.
Which is one reason why deja vu experiences can be a little bit unnerving, because they're upsetting that sense of what actually happened when.
Yeah.
Do we ever have the chance to escape ourselves? Because when I get it right, is that we see the world, how we see the world depends on how we are constructed. So we see the world as we are, and with all the limits that we are. So everything that scientists ever think about, that they want to prove, comes, that it's a self-referential, so it's a closed system kind of. So we can only see and prove and think about based on our own experience, and our own experience might be based on how we are constructed as humans. So if this would be like that, I don't know, but this is what I see. My question is, can we ever experience anything or think anything that is outside of how we are already constructed, like very limited? So can we escape our own assumptions?
I guess my answer from my own experience would be occasionally, slightly, and not very well. But you've very nicely stated the core of Kantian metaphysics, which is that we have a particular structure, and you can think of it as a physical structure, or a biological structure, or a cognitive structure, however you want to, at whatever level of description you like. And that structure imposes itself on and enables our experience. And if one thinks of it that way, then your question has real teeth. Because in a sense, one ends up not being able to have experiences that one is not enabled to have. But we also know by looking at the experimental literature, the pathological literature, the spiritual literature, all of these different reports of experience, that humans are capable of a vast number of different kinds of experiences. And I think a very interesting question, which is not discussed nearly enough, is what do we actually mean by sanity? What is this concept of sanity by which we draw a boundary around the kinds of experiences that we think of as acceptable in some sense, and treat other types of experiences as, in a sense, unacceptable or pathological. And it's very strange, the sorts of experiences that we treat as acceptable in many cases.
There must be I think there could be a huge field we don't even know that we don't know it, which
Yeah.
I think...
Yeah, I think that's exactly right. I mean,
and all experience, even if they are called insane or spiritual or whatever, are still in the scope of how we are constructed.
Yeah.
Yes.
And that, of course, is why psychedelics are so interesting, because we're changing, the way we construct our experience of the world. We're stepping out the normal biological thing. We're changing the neurophysiology in some way, where we actually reconstruct the world in a way which is very different from normal experience, and is called insane sometimes.
It was a very interesting talk. Thank you very much. I'd like to comment that I'm developing a new theory of gravity that adds consciousness or the observer into the equations. And the idea is similar, that actually we are all observing the universe from the same point, which is not a point in space or time, but this is a conceptual point of unity. And it's actually an extension of quantum mechanics into the larger scales, in the idea that when I'm observing a galaxy there, I'm actually affecting it because we're all connected. So it's quite in line with your ideas, so I'll be happy to discuss it with you later on.
Okay.
Thank you.
Thanks.
Okay.
Interact. All process of creating information get some energy in it. How do you see the end of it? Is it the death we all speak about? We are as memories and so on. What happens when the observer is dying? Where is the energy is going? Where is all what's there? What's the process? There is constant energy in the world, or is it expanding and moving? How do you see death in your system?
If quantum theory is correct, the amount of energy in the universe as a whole is constant. And experimental evidence, at least, indicates that energy is conserved in all the arrangements by which energy conservation measurements have been made. So it's an assumption, at least, that the energy in the universe is conserved. But that says nothing about the energy in a particular part of the universe. And that can be varying wildly, of course. So the question, what happens to information at death? I have no idea. And thinking about it biologically, it is just recycled into other life forms. If you think of everything as an observer, then even the macromolecules in your body are observers that are storing information, and they may be giving that information to bacteria or other parts of the environment or anything else. So if we can think of this whole process that we are part of as an exchange of information between let's see what the language here would be, things that we regard as things that we regard as separate entities, but in a sense aren't separate entities.
Yep. My question is, which one comes first, the information or the observer? Is it the information that structures the observer to be a means of exchange, or is it the observer that is creating the information?
That's a very subtle and interesting question. And I would phrase that as the question, why are there any boundaries at all in the universe across which interaction happens, across which information is transferred? And if you don't believe that boundaries are objective, then you can't say, well, there's some boundaries in the universe and that's that. You can only say that from some point of view, there is a boundary here. And from that point of view, information is exchanged across that boundary. But of course, that begs the question of what the point of view you're talking about is. And from a straight physics point of view, I think the answer that one comes to is that boundary drawing is completely arbitrary. And all statements about information flow are conditional, in a sense. There's no such thing as objective information flow. Which you could rephrase that as, there's no such thing as objective experience. All experience is conditioned on a point of view. So all descriptions of experience, in a sense, are question-begging. Now, that's an elaborate way of not answering your question. But I think it at least illustrates a way of thinking about this, and that the question is in itself paradoxical. That there does not appear to be a way to escape the question-begging nature of that response, at least for me.
But does the observer have the capacity to alter the information?
Everything the observer does alters the information that flows. Everything that the observer does alters what's happening on the other side of the observer.
Okay, let's just take one more.
Okay. If I am correct, your calculation shows that the universe has enough mass or energy to store information about itself. But what about imagination and creative processes that happen in our brains or in some other places? What about this data coming from somewhere else that goes through us? Is it stored somewhere else, like outside the observable universe? Or, I mean, does imagination, how data we imagine, enter into your theory?
Let's see. Certainly the way I did those very simple calculations was from the perspective of deep space itself, right? Where the observers that exist are very, very simple observers, okay? And an assumption there is that the current thinking about the amount of mass in the universe is roughly right. That says, you know, roughly 5% of the stuff in the universe is the kind of stuff that we are. And, you know, 25% is dark matter, whatever that is, only detected gravitationally, and the rest of it's dark energy. And so I focused on the dark energy bit and treated the stuff like we are, the 5%, as basically irrelevant. So what's going on in our world, which, yes, involves lots of processes that are imaginative, at least from a physics perspective, imagination is information that's being generated, and it's being generated by a system that must consume energy to generate it. So we are all imaginative beings that have to feed on the environment in order to construct imaginative thoughts or to be creative. And that would apply also to bacteria, for example, to any kind of organism at all, is in this situation of constructing information out of free energy. So it does assume that there's lots of free energy available.
Okay, thank you. I think we should wrap up. Thank you all. Thank you, Peter.